Today I will be presenting a case study on the municipal solid waste and hazardous waste. The first article that I found related to the municipal solid waste is titled as Municipal Solid Waste. The author of the article is Angel Chettiparam and was published on 2012. The second article that I found related to the municipal solid waste is titled as Municipal Solid Waste Management and Disposal. The author of the article is Digambar Singh and that published on 2009. The last article that I found related to the municipal solid waste is Waste Characterization Study of Municipal Solid Waste Disposal at Bochum Ipoh. And the author of the article is Yana Shamimi binti Ghazali and they published on 2009. The first article that I found related to the hazardous waste titled as Computer Aided Landfill Design for Hazardous Waste Disposal. The author of the article is Shika Verma and they published on 2003. The second article that I found related to the hazardous waste titled as Underground Hazardous Waste Disposal, a dynamic alternative to current hazardous waste management. The author of the article is Maria Melgati and they published on 2004. The last article that I found related to the hazardous waste titled as Risk Assessment for Hazardous Waste Disposal in Abandoned Mines. The author of the article is Robert Ade and published on 2002. Now, let's begin with the disposal problems in the first article of municipal solid waste. Based on the article, the disposal problem for municipal solid waste can be evaluated as follows. The first one is natural science analysis. The article discusses the nature of municipal solid waste, MSW, and its environmental impact. It highlights the variation in waste characteristics based on industrialization and climatic conditions, as well as differences in waste between developed and developing countries. The article also clarifies MSW into organic and inorganic wastes, providing scientific basis for understanding the composition of waste. The scientific theories presented in the article provide a comprehensive understanding of the nature of MSW and its environmental implications. However, the limitation of these theories, such as the variability of waste characteristics, should be considered when predicting the reality of waste disposal. The second one is engineering fundamentals analysis. The article outlines various managerial practices associated with MSW, including storage and collection, transportation, and disposal practices. It also discusses the historical growth of MSW as an environmental problem and the geographical variation in waste management. The article evaluates more than 4 circumstances related to waste disposal, providing evidence to support generalization about the engineering fundamentals of MSW management. The third one is specialist knowledge. The article extrapolates ideas and content for use in different specialized engineering situations, particularly in the field of environmental pollution control. It explains the principles, theories, and methodologies in specialized knowledge of waste management, providing a comprehensive understanding of the environmental implications of waste disposal. The fourth one is engineering design. The article discusses various disposal options of MSW, including incineration plants, compost plants, landfills, and anaerobic biogasification plants, considering economic, safety, and environmental constraints. The fifth one is knowledge of issues and approaches. The article extrapolates ideas and content for use in different issues and approaches engineering technician practice, such as public safety, environmental, and sustainability development. The sixth one is familiarity of issues. The article compares and differentiates various issues related to waste disposal, including to the historical growth of MSW, geographical variation in waste management, and nature and quantity of domestic solid waste. The last one is extent of applicable codes. The article references several practicing guides, codes, and acts related to waste management, including the Basel Convention, DEFRA's definitions of waste streams, and UNEP's classification of MSW. That's overall, the article provides a comprehensive evaluation of the disposal program for municipal solid waste, covering natural science, engineering fundamentals, specialized knowledge, engineering design, knowledge of issues and approaches, familiarity of issues, and extent of applicable codes. Let's see disposal problems in the second article of Municipal Solid Waste. Based on the information provided, the disposal problem for municipal solid waste (MSW) is a complex issue that requires a multifaceted approach to address. The first one is natural science. The problem of MSW disposal involves the application of natural science theories to engineering solutions. For example, the use of incineration as a thermal process to convert the organic portion of MSW to gases and the inorganic portion to ashes is an application of natural science principle to address the volume of waste. The second one is engineering fundamentals. The disposal problem involves the analysis of specific principles, theories, methodologies in engineering fundamentals. For example, the use of transfer stations for classification and processing of waste, as well as the separation of waste components for recycling are engineering fundamentals applied to disposal. The third one is specialized knowledge. The specialized knowledge of environmental pollution and control is essential in addressing the disposal problem for MSW. It includes understanding environmental impacts of various disposal methods and the development strategies for waste reduction and resource recovery. The fourth one is engineering design. An engineering design approach is necessary to address the disposal problem, taking into account economic, safety, environmental, and other constraints. This may involve designing waste management systems that prioritize waste reduction, recycling, and energy recovery. The fifth one is knowledge of issues and approaches. The disposal problem requires an understanding of various issues and approaches to engineering technician practice, such as public safety, environmental sustainability, and waste management. This includes developing strategies for waste diversion, composting, and incineration with energy recovery. The sixth one is familiarity of issues. The disposal problem involves comparing and differentiating various issues such as waste reduction, recycling, and landfill management to develop comprehensive waste management. The last one is extent of applicable codes. In addressing the disposal problem, it is important to consider and apply relevant practicing guides, codes, and acts related to waste management, environmental protection, and resource recovery. This includes regulation, governing, and design and operation of disposal facilities, as well as standards for waste classification and recycling. In conclusion, the disposal problem for municipal solid waste requires a comprehensive and interdisciplinary approach that integrates natural science, engineering fundamentals, specialist knowledge, engineering design, knowledge of issues and approaches, familiarity of issues, and extent of applicable codes to develop effective management of energies. Now, let's see the disposal problems in the third article of Municipal Solid Waste. Based on the article, the disposal problem from municipal solid waste can be evaluated as follows. The first one is natural science analysis. The theory of waste characterization and quantification can be applied to engineering solutions for waste disposal, such as landfill management and recycling programs. The theory predicts the reality of waste generation composition, which is essential for effective waste management. The scientific theories of waste characterization and quantification are valued for understanding the composition and generation of municipal solid waste. However, there are limitations in predicting the exact quantities and types of waste generated in different locations. The second one is engineering fundamentals. The principle of waste characterization, sampling, and analysis are fundamental to understanding the specific composition and quantities of municipal solid waste. This information is crucial for designing waste management systems. The circumstances of waste characterization, sampling, and analysis in the article are well explained and justified, providing a comprehensive understanding of engineering fundamentals involved in waste disposal. The third one is specialist knowledge. The specialized knowledge of environmental pollution and control is essential for addressing the disposal problem of municipal solid waste. Understanding the impact of waste on the environment and control measures is crucial. The article provides detailed information on the chemical and physical properties of municipal solid waste, contributing to specialized knowledge in environmental pollution and control. The fourth is engineering design. An effective engineering design for waste disposal must consider economic, safety, and environmental constraints. It should aim to minimize the environmental impact of waste disposal while ensuring public safety and cost effectiveness. The fifth one is knowledge of issues and approaches. The article extrapolates ideas and content for use in different issues and approaches in waste management, such as landfill management, recycling programs, and energy recovery from waste. The sixth one is familiarity of issues. The disposal problem for municipal solid waste involves issues such as waste composition and environmental impact. Understanding these issues is crucial for developing effective waste management strategies. The last one is extent of applicable codes. The article references various producing guides, codes, and acts related to waste management, providing a comprehensive understanding of the regulative framework for waste disposal. In conclusion, the article provides valuable insights into the disposable problem for municipal solid waste, covering natural science, engineering fundamentals, specialist knowledge, engineering design, knowledge of issues and approaches, familiarity of issues, and extent of applicable codes. It offers a comprehensive understanding of waste management principles and practices.
Now we move on to disposal problems in the first article of hazardous waste. Based on the article, we can assume that the engineering application of natural sciences to the problem of hazardous waste disposal involve the use of mathematical calculations and scientific principles to design landfill that do not pollute air, water, or soil. The software uses mathematical formulation to calculate the volume of waste, cover system, and liner system required for safe disposal. Next is engineering fundamentals. The software allows for the inputs of specific parameters such as the number of industries, growth rate of industry, estimated waste generation, and density of the waste. It is to calculate the total volume of waste, volume of daily cover, and volume of the landfill. Next is specialist knowledge. The software is designed to meet the specialist knowledge requirements for environmental pollution and control, as it takes into account guidelines provided by the Central Pollution Control Board and the Ministry of Environment and Forests. It also allows for the modification of default values by specialists, ensuring that meaningful and acceptable data flow into the system. Fourth, engineering design. The engineering design aims to design landfill that do not cause harm to human beings and the surrounding habitats. The software also calculates the total quantity of hazardous waste disposed and the volume of landfill needed to accommodate the waste, providing a comprehensive design for safe disposal. Fifth, knowledge of issue and approaches. The software addresses the issue of hazardous waste disposal by providing a tool for waste management officials to design engineering landfill that meets the guideline provided by governing bodies. It allows for the modification of rules and guidelines to make it applicable for other countries. 6. Familiarity of issues. The software addresses the issue of waste generation, storage, treatment, transport, recycling, recovery, and safe disposal. And the final one is extent of applicable codes. The software is based on guidelines and manuals provided by the Central Pollution Control Board and the Ministry of Environment and Forests, ensuring that it complies with the applicable codes and acts for hazardous waste management in India. Okay, now we go to the second article. Okay, the first one is natural science. The article discusses the use of natural geological barrier in deep underground disposal facilities to protect water sources from contamination. This application demonstrates the use of theory to predict and address real-world environmental risks. Second one, engineering fundamentals. The article evaluates the construction and operational issues of underground hazardous waste disposal facilities, including the use of artificial barrier and the need for risk assessment. Also discuss the cost differences between surface and underground disposal facilities. This analysis provides a thorough evaluation of the validity and limitation of scientific theories related to engineering fundamentals. Third one, specialist knowledge. The article extrapolates ideas and content for use in different specialized engineering situations, such as the selection of disposal techniques based on the physical state of waste streams, mine layout, and hydrogeology. It also discusses the needs for waste acceptance criteria and risk assessment studies. This demonstrates a deep understanding of specialized knowledge in environmental pollution and control. Next, engineering design. The article presents the concept of using abandoned mines for hazardous waste disposal as an engineering design that includes economics, safety, environmental, and other realistic constraints. It evaluates the advantages of underground disposal and the cost differences between surface and underground facilities. Next, knowledge of issues and approaches. The article extrapolates ideas and content for use in different issues and approaches in engineering technician practice, such as public safety, environmental protection, and sustainability development. It discussed the need for environmental monitoring, wastewater treatment, and financial insurance, as well as the advantages of utilizing underground mines as hazardous waste repositories. 6. Familiarity of issues. The article compares and differentiates issues related to hazardous waste disposal, including the use of landfill, incineration, and underground storage. It also addresses the need for waste prevention and minimization as a long-term solution for waste management. Lastly, extent of applicable codes. The article references European Council decision, European Directive, and the Landfill Directive as applicable guides and codes for hazardous waste management. It discusses the exclusion of underground storage facilities from certain obligations that apply to landfill, highlighting the differences in regulatory requirements for different disposal methods. Right now, we move on to the final article. First, natural science. The document discusses the use of geological structures, rock mechanical modeling, and flow and transport modeling to predict the behavior of hazardous waste in abandoned mines. The theories and methodologies used in the document are expected to predict the rarity of hazardous waste disposal in various geological media. Second, engineering fundamentals. The document evaluates more than 4 circumstances, such as the selection of suitable mines, transport of waste material, and cost of preparing the mines for waste storage, with acceptable justification. The third, specialized knowledge. The document extrapolates ideas and content for use in different specialized engineering situations related to environmental pollution and control. It explains specific principles, theories, rules, and methodologies in specialized knowledge of hazardous waste disposal, including the assessment of risk, rock mechanical modeling, and flow and transport modeling. Fourth, engineering design. The document evaluates the design of reference mine depositories, the selection of suitable mines, and the preparation of abandoned mines for waste storage. Fifth, knowledge of issues and approaches. The document extrapolates idea and content for use in different issues and approaches in engineering technician practice, such as public safety, environmental and sustainability development. It addresses issues related to geological structure, transport of waste material, and the cost of preparing the mines for waste storage. Next, familiarity of issues. The document compares and differentiates three issues related to hazardous waste disposal, including the geological structure, transport of waste material, and the cost of preparing the mine for waste storage. Lastly, extent of applicable codes. The document references more than 3 practicing guides, codes, and acts related to hazardous waste disposal, including risk assessment modeling, rock mechanical modeling, and flow and transport modeling with acceptable justification.
I will now begin the presentation with municipal solid waste. Every day, our homes, businesses, and institutes generate a significant amount of waste, municipal solid waste. These include items like food, scraps, packaging, yard waste, furniture, and more. While municipal solid waste may seem like a mundane issue, its management has significantly ethical, technical, and environmental implications. Finding sustainable solution requires a multifaceted approach that considers the entire waste hierarchy, from reducing waste generation at the source to responsible disposal. Let's delve into the complexity of municipal solid waste management and explore some effective strategies for a more sustainable future. Ethical issue and inclusive behavior for municipal solid waste. I have 4 points for this. First is reduce and reuse, recycle and compost, waste to energy and landfill disposal. So I'll be explaining more deeper these 4 points in the upcoming slides. The first point is reduce and reuse. So reduce and reuse is about promoting responsible consumption through public awareness campaign, encourage people to buy less, choose products with longer lifespans, and find way to use items before discarding them. This reduces the overall burden on the waste management system. Second point is recycle and compost. Effective recycling programs rely on clear guidelines for residents. Providing information in multiple language and format ensures everyone understands what materials can be recycled and how to sort them properly. Additionally, ensuring equitable access to recycling facilities throughout the community prevents certain areas from becoming dumping grounds. Third point is waste to energy. While incineration can offer some benefits like energy generation, it raises ethical concerns about air pollution. Prioritizing advanced facilities with robust emission control system minimize the health risk associated with air pollution and ensure the surrounding communities are not disproportionately impacted. And the last point is landfill disposal. Landfill, though a last resort, should be managed ethically. Proper engineering ensures leachate, which is contaminated water draining from landfills, is collected and treated to prevent groundwater contamination. This protects surrounding communities and water sources. The second part for municipal solid waste is technical and engineering concentration. For this part, I have 2 points, which is waste characterization and infrastructure development. So what is waste characterization? So waste characterization is analyze the composition of municipal solid waste to optimize collection method and design efficient processing facilities for recycling, composting or waste to energy conversion. The last point for this part is infrastructure development. So we should invest in sorting facilities, recycling plants, composting infrastructure and potential advanced incineration with energy capture. So the last part for municipal solid waste is environmental and social impact quantification. So for this part also I have 2 points, which is life cycle assessment LCA and finally social impact assessment SIA. Life cycle assessment LCA is about conduct LCAs to compare environmental burdens of different management options. Consider greenhouse gas emission, resources depletion, and potential for water or soil contamination. Final point is social impact assessment SIA. Evaluate the social impacts on communities, including job creation, potential health risk from facilities, and equitable access to waste management service. So we are now at the last part of the presentation, which is hazardous waste. So not all waste is created equal. Hazardous waste, a specific category of municipal solid waste, poses a much greater threat due to its inherent properties. These materials, often from industrial processes or household, can be toxic, flammable, corrosive, or reactive. So, improper handling of hazardous waste can have devastating consequences for human health and the environment. So, managing this type of waste requires a stringent and specialized approach that prioritizes safety, ethical disposal practice, and minimizing environmental impact. In this discussion, we will explore the unique challenges and solutions associated with hazardous waste management with the same 3 points that I've been explained for municipal solid waste. So for this part, the first one is ethical issue and inclusive behavior. I have 2 points, which is strict regulation and community outreach. Strict regulation is implement and enforce clear regulation for hazardous waste generation, storage and transportation including disposal. Last point is community outreach is educate businesses and residents about proper hazardous waste disposal procedures and the potential consequence of improper handling the hazardous waste. The second part for hazardous waste is technical and engineering concentration. So for this part also I have 2 points, which is treatment and disposal facilities and transportation infrastructure. Treatment and disposal facilities is invest in specialized facilities for treatment like chemical, thermal, biological and secure disposal, landfills with stringent linears and monitoring. Transportation infrastructure is about ensure safe and secure transportation of hazardous waste with proper labeling, packaging and spill prevention measures. So this is to make sure the waste is transported out and in safely. We are now at the last part, which is environmental and social impact quantification for hazardous waste. So for this part also I have 2 points, which is risk assessment and community engagement. Risk assessment is about conduct comprehensive risk assessment to identify potential environmental and social impact associated with hazardous waste management facilities. And the last part of my presentation is community engagement. Engage with communities potentially impacted by hazardous waste facilities, addressing concerns and ensuring transparency.